I don't think
Yes, sir. Have we started it?
I don't think so, sir.
Then, can you tell me what was our last case?
Um uh is it the one where it's going up?
Look at the screen. I think this was the last case, perhaps case number 4.
So
I feel I have done this.
we also did case number 5.
Hmm?
We also did case number 5, sir.
What about this one? Is it there in your copy in the copy?
Yes, sir.
Please, everyone confirm that case number 5 is present in the copy.
Yes, sir, it is.
Then we are rightly on the position table cases. Connected objects. Table cases, connected objects. Copy this.
Done, sir.
Now, remember those steps which we did there. So we are discussing the table cases. So whenever you come across a question, you have to remember the steps. We have discussed the steps, and we should remember that this is the method steps. So whenever you come across a question, you have to remember these steps. Okay. These are the steps. You have to identify all the forces. Identify it's a case of equilibrium or resultant force. This is like a question mark, and make equations and solve if needed. Solution of the equation is not always needed. Now look at this diagram. You have to double check is it there or not, but I'm not sure if I have drawn it, you people have drawn it or not. There is a string and there is a pulley. The string is passing over a pulley and the two blocks are there. One block is resting on the table and the other block is on the hanging side. So please double check and copy it if it is not copied yet.
So we copied this.
In the last class, right? You had
Yeah.
copied it.
Yeah. Cool. I didn't really understand it, so
It's the start of this topic, and other people should also confirm. And now the time is there to apply this method. Identify all the forces. It's a string. It's a string. It is a pulley and two blocks. So what are the forces in the system? What are the forces in the system? One is the tension, R is the normal reaction, F is the friction. Now you can see I have shown all the forces in the system.
okay, sir.
So check it if it is there. I think we had made these forces also. Now, these are the forces, and the system is showing that the tension is there in the string. Normal reaction is upward, weight is downward, friction is backward, because the objects, obviously the hanging object will try to move downward. The hanging object will try to move downward.
Yes, sir.
Now, again, see the steps. Identify the forces. The forces are identified. Now, examiner will tell you in the exam that this is a case of equilibrium or resultant by giving you some hints. Remember, when a system is in equilibrium, it is either at rest or moving with constant velocity. If a system is at rest, if a system is in equilibrium, it is either at rest or moving with constant velocity. I also want to recall, which I was discussing when the last class was ended, that is the contribution of the pulley. Pulley is by default a frictionless object. And look, there are two tensions on the pulley. There are two tensions on the pulley. Look at the screen. One is this tension and second is this tension. I have shown it here in a separate diagram. Why there are two tensions, 1 and 2? Why there are two tensions in one string? Because one of them, if it is the action, the other tension in the same string applying on the pulley is the reaction. Now, how we can solve this? We can find the resultant of these two tensions. How we
Sir,
can find the resultant of these two tensions?
subtracting them?
No. Remember how we can find the resultant of two vectors?
Oh yeah, hypotenuse, sir.
Yes. So now upgrade the same diagram and find the resultant. I have made a right angle triangle and I have used Pythagoras theorem.
Sir, tension, can you explain what tension is, sir?
Tension is the stiffness in a string. Tension is a stiffness in a string.
Is the what, sir?
Tension is the stiffness in a string. So when you hang something, if you have a chance of playing tug war is the tension example in the string. So when you hang something from a string or you pull out something with a string, the string is taut. The tautness, the stiffness is the tension. So tension is the force in the string when it is stretched.
Okay, sir.
So I have repeated many concepts, and as I mentioned, this is the core of this chapter. This is a big chapter. It comes every year. It is a club with kinematics, but kinematics is not that much challenging. Kinematic sketches are very challenging, no doubt, but this topic we are doing is very, very challenging. Now, I put an example from the past paper to show that what are the ways examiners can ask a question. This is an example. 8 kg mass is resting on a rough surface. What's the meaning of rough? Does it mean friction is there or friction is not there?
Friction is there, sir.
2 kg mass, right? 2 kg mass is hanging. And what is the meaning of the word smooth pulley?
Frictionless.
Yes, it means pulley is frictionless, table surface is rough, and the two masses are there. And the two masses are there. One is hanging and one is on the table. Now, you people have to copy it. This past paper reference question. I'm just coming. Please copy it. I have shown all the forces on the diagram. And I'm saying the question is in equilibrium. So please update the same diagram. Show all the forces. Let me know once you people are done with the diagram updating. Equilibrium. Whenever a system is in equilibrium, forces are balanced. Whenever a system is in equilibrium, forces are balanced.
So what is that 8G?
8G, G is 9.8. It's a weight now.
For
8G is a writing style.
the,
8G
the
means 8
force
into 9.8. It's a weight.
the force acting downwards on the 8 kg
Hmm.
weight. What is it?
Yes, this is the weight.
Okay.
So you people have updated the diagram. Want to get again on my last class work of equilibrium, that whenever you talk about equilibrium, when a system is in equilibrium, forces are balanced on same axis, same axes. When a system, when a when a system is in equilibrium, forces are balanced on same axes. It's a very important concept to understand, and that actually helps to make the equations also. Now, for example, this is a block and it is on a surface. This is the driving force and this is the friction. System is in equilibrium. Suppose this is the mass, then this will be mg and there will be an upward force R. So when a system is in equilibrium, remember the logic which we applied. The logic is there that right is equal to left. Right is equal to left. Here it means that F is equal to small f. And when you say up is equal to down, when you say up is equal to down, here it will mean that R is equal to mg. This is a concept to understand when you are facing or when you understood that the system is in equilibrium. You have to copy this.
Done, sir.
Okay, good.
Done, sir.
Now, when a system, the second case, which when a system is accelerating use, ma is equal to greater force minus smaller force. You have to copy this now.
Okay.
Answer.
If a system is in equilibrium, you have to equate the forces. If the system is accelerating, then you have to change the plan. And I'm giving you an example again that I have a block of suppose 2 kg. The block is resting on a surface like this. And I'm applying a force on the right hand side, this one, and the force is X. The backward force, this one, the backward force, for example, is tension. And the object is accelerating to the right. The object is moving to the right. Now, carefully see how we make equations. Formula says MA is equal to greater force minus smaller force. So I will write 2A is equal to the greater force is X minus T. This is how we write down the equations. So if you carefully understand this sheet and you understand this sheet, these two concepts, then the problem would be over, because every time either it is a case of equilibrium or it is a case of resultant force, acceleration case. Now you have to copy this screen.
Done, sir.
Answer.
Now you have to go back to the situation where we left them and we made these rules here. And we were on a question and we were on an inclined plane, we were on a table case question. Look at the table case. The system is in equilibrium. You people have copied it. Now you people have to help me in making the equation. You have to make an equation. I'm making the first circle and I'm making a question mark. What would be the equation? Equilibrium means up is equal to down and right is equal to left.
Yes, sir.
So what would be the equation for the first circle?
So 2G is equal to T.
Other people also contribute. 2G is equal to T.
Yeah.
So other people should also contribute.
But sir, what about like the tension produced by the pulley?
Again, this is balanced now.
Okay, understood. So that tension only happens when like there's a resultant force, yeah?
Sorry.
That tension from like a pulley, like like you said that it's like going outwards from the pulley, yeah, like the tension.
But pulley is intact now. So it means pulley is actually able to withstand the tension. Pulley is not moving. Pulley is presently the system is in equilibrium. So pulley is moving or stationary, but pulley is not getting out of the position. So you should remember that the two tensions from the pulley are giving a resultant, that is the strain on the pulley. But pulley is in its place. This is the case. If pulley breaks, then it's a case. Now I'm putting my I am putting my second circle and I'm putting a double question mark here. You have to help me in writing the equation.
EG is equal to R.
Okay. Eight G is equal to R. Now,
Yeah.
the question mark. The system is in equilibrium.
The T is equal to F.
T is equal to F.
Yeah.
T is equal to F. So we have discussed all the equations and now you have to update the screen. You have to copy all these equations.
Okay, sir. Done, sir.
Sir.
Now I'm putting the case of acceleration.
Sorry, sir.
I'm putting the same situation
Yeah.
for same diagram for acceleration.
Okay.
So copy the case again.
Okay, sir.
But this time it's a case of acceleration. Predict what is the possible direction of motion if one object is hanging. If one object is hanging, it will be going down. This is acceleration here. And it will be going to the right. So update the same diagram. Now, you people have to tell me the equations. Remember the formula, greater force minus smaller force is equal to MA. I have put my question mark. Remember the formula, greater force minus smaller force is equal to MA.
So, is it MA is equal to 2G minus T?
Other people also please help me. Greater force minus smaller force. So this is the mass. Okay, I will write 2A MA is equal to greater force is 2G, 2G minus T.
Okay.
MA is equal to greater force minus smaller force. Now, I'm putting my acceleration for the second one. It's a rough surface. So there will be a backward friction. Now I put a double question mark here for the second equation.
Sorry, sir?
Look at the double question mark. Okay. 8A equals T minus F. Good answer. Hasat, your answer please on the double question mark.
Okay, so it's gonna be F minus T. Sorry. 8A. 8A is equal to T minus F.
8A is equal to T minus F. Now, there is no motion in the direction of, R and mg. So they will not produce any acceleration. So they will be equal to be directly equated. They are not moving. The object 8 kg mass is not moving in the direction of R or in the direction of 8g. So there is no motion there. So you will be just equating them.
Okay.
So now we have the equations. Now update and copy down the equations. Copy that. I'm just coming. Please copy that.
Done, sir.
Now let's try a real full question. You have to look at this question. First, read it. A mass of 2 kg rests on a frictionless surface. There is no friction. It is attached to a 1 kg mass by a light thin string which passes over a frictionless pulley. The 1 kg mass is released and it accelerates downward. What is the speed of the 2 kg mass as the 1 kg mass hits the floor, having fallen a distance of 1.5 meter? You have to please call. No need to copy the question. Just you can refer to year number. You can copy the diagram if you want for the forces.
Sir, I don't know how to do it.
I have shown all the arrows. So please show
Yeah.
the arrows with me. There is no friction. Please show all the arrows.
So what's gonna be T?
We do not know T. We do not know tension. We do not know acceleration.
Okay. So how do you know the forces?
Forces are like tension, weight. The red tension is the reaction force, Newton's third law. The blue tension is the applied force. And whenever you show a string in A level, remember that there are two tensions, one at one end and second on the other end.
Okay.
System is accelerating. So please make the equations. Make the equations.
So why
You have
is
to be
it
a bit quick.
why is sigma F equal to T?
Sorry.
Why is sigma F equal to T?
Where sigma?
The second.
That's the only resultant force. That's the only force. Now, this time there is no friction. This time there is no
Oh, okay.
friction. So tension will be equal to the resultant force. Now you people have to solve simultaneously to get rid of T.
Sure.
Please solve it simultaneously and find the acceleration.
Okay, sir. Sir, is A 3.3? 3.27?
I'm getting acceleration as 3.27.
Okay.
Then you have to put you have to put the acceleration. You have to put the acceleration in the equation to find speed.
Okay. Okay, understood, sir.
So I have solved this simultaneously, got the value of acceleration. Then you put it back and get the value of the velocity which we are looking for. Initially, the system was at rest. So U is equal to 0. So please complete it and give me the update.
Done, sir. It's the answer. The answer is 1.8. Yeah. Okay.
The answer would be A.
Okay.
So everyone copy it. Let me know once you all people have copied it.
Done, sir.
Okay.
Done, sir.
This is the concept of resultant force connected objects. So we keep it up to here. We keep it up to here, and we will inshallah continue in our next class.
Okay, sir.
Allah Hafiz.
Left, sir.
Love is, sir.